Hello everyone. Welcome to today's webinar on Deep Learning Frameworks for Convolutional Neural Networks. I'm Prashanti Sudhakar and I'm excited to be your host for this insightful session. In this session, we'll dive into how AI-driven tools including deep learning frameworks for convolutional neural networks are revolutionizing training programs, enhancing knowledge retention, and fueling ongoing growth in organization. Prepare for an engaging experience featuring real-world case studies, practical applications, and actionable insights you can start implementing immediately. Let's dive into the future of learning where AI meets human potential. At Education Nest, we are committed to empowering professionals with cutting edge training and resources to help them stay ahead in today's fast evolving landscape. Let's dive in and make this an engaging and insightful session. Let me now start by setting the stage for the webinar by introducing our topic, Deep Learning Frameworks for Convolutional Neural Networks. Convolutional neural networks are a powerful type of deep learning model specifically designed for image and visual data processing. Unlike traditional machine learning models that require manual feature extractions, CNNs automatically learn patterns such as edges, textures, shapes, and objects from raw images. CNNs have revolutionized the field of computer vision, making significant advancements in areas like image classification, object detection, facial recognition, medical imaging. In this seminar, we will explore CNN architecture, working principles, key applications, and future trends in deep learning. We have an amazing speaker for today's webinar, Dr. V. Ajanta Devi. She received her PhD from University of Madras in 2015. She has worked as a project fellow under UGC Major Research Project. Ajanta Devi Vairamani is a certified artificial intelligence engineer formally evaluated for experience, knowledge, and demonstrated competency in AI as per industry standards established by USAII. She has been certified as Microsoft Certified Application Developer and Microsoft Certified Technical Specialist from Microsoft Corporation. She has more than 50 papers in international journals and conference proceedings to her credit. She has written, co-authored and edited a number of books in the field of computer science. She is a senior member of IEEE as well, associated as a member of the program committee, technical committee, chair, review board for a variety of international conferences. She has 5 Australian patents and 1 Indian patent to her credit in the area of artificial intelligence, image processing, and medical imaging. Her work in image processing, signal processing, pattern matching, and natural language processing is based on artificial intelligence, machine learning, and deep learning techniques. She has won many Best Paper Presentation Awards as well as a few research-oriented international awards. During this session, feel free to drop your questions in the chat. We'll wrap up with a very exciting question and answer session at the end. So don't hesitate. Let's keep this interactive. Ajanta Devi ma'am, thank you so much for joining and it's my pleasure to meet you again in another webinar. The stage is all yours, ma'am.
Yeah, thank you and thank you for the opportunity. Yeah, let I just go for the session. Okay. First of all, the screen is visible. Yes?
Yes, ma'am. Yes, it's visible.
Yeah. Yeah, happy evening, dear friends. And today we are just going to discuss about a deep learning framework for convolutional neural network. Of course, Prasanthi has also already given you a small intro about what we are just going to discuss. Let I just dive into the exact session. Dear friends, this exact, that is what we can just say, the matching or comparative, already we have just seen a lot in our previous, but anyhow, I just give you again a small intro about what is artificial intelligence, what is machine learning and the deep learning. Dear friends, artificial intelligence is a broader term that describes the capability of the machine to learn and solve problems just like humans. In other words, AI refers to the replication of humans, how it thinks, works, and functions. On the lower ground, AI can be seen as a program that instructs the machine to function in a certain way according to the situation. And there are two ways of incorporating intelligence in artificial intelligence things, that is to achieve artificial intelligence. One is through machine learning and another is deep learning. And machine learning, yes, of course, dear friends, now that we have understood the term AI, we can take a closer look on machine learning and deep learning. And here it comprises algorithm for accomplishing different types of tasks, such as classification, regression, even clustering. So the accuracy of algorithm increases with an increase in data.
So sorry, ma'am.
Analyzing
Excuse
and
me.
learning. Yes,
One
yes.
second. Ma'am, your video is stuck and I think there's some network problem or something. Uh,
1 second.
we are not being able to hear your voice in clarity, actually. Can you please
Is
check
it?
with
Is
me?
it? 1 second. One
Yeah,
second.
yeah. Can you speak again? I think I can see your video, but
My video is visible, of course. Yeah. Am I audible now?
yeah, yeah. Now it's good, ma'am. Please continue. I'm so
Oh,
sorry to interrupt.
yes. No
Yeah,
problem. No problem. Okay.
thank
Anyhow,
you.
yes, dear friends, I just come again. Yes, of course, AI is a border term that describes the capability of machine to learn and solve problems, just like human. And in other words, AI refers to the replications of human, how it thinks, works, and function. And of course, machine learning comprise algorithm of accomplishing different types of tasks, such as classification, regression, or clustering. And the accuracy of algorithm increases. It is not according to increases. Of course, there would be a changes where you change the size of the data. And dear friends, analyzing and learning from data come around under the training part of the machine learning model. And during the training of the model, the objective is to minimize the loss between actual and towards the predicted value. And when coming towards the deep learning, dear friends, deep learning is an emerging field that has been in the steady use since its inception in the field in 2010. And it is based on an artificial neural network, which is nothing but a mimic of the working of a human brain. Just like machine learning model, the deep learning model requires a large amount of data to learn and make an informed decision and is therefore also considered a subset of machine learning. This is one of the reasons for the misconception that machine learning and deep learning are the same. No, however, the deep learning model is based on artificial neural network, which have the capability of solving tasks which machine learning is unable to solve. The future is driven by deep learning models. Without deep learning, Alexa or Siri or Google Voice Assistant or Google Translation, self-driving cars are not possible. And dear friends, of course, we have already seen this image in our school time itself. It's simple term. The fundamental job of the neuron is to receive and transmit impulse. That is impulse in the sense information in various parts of our own body. In a simple neuron, which forges building blocks of our human neuron nerve system. By the way, there will be no single neuron. The building block generates millions and millions of neurons. Just think of the circumstance as a car accident happened in front of our flat, which our brain will think immediately or go for help if feasible to seek assistance, if not contacting that ambulance. So here, while we have seen so many neural elements, this dendrites are regarded as a signal receiver and axon as a signal transmitter. And here, of course, this is our neuron structure, which we just specify as a typical neuron. But yes, we are going to make better understanding. We are just going to have it in a signal form a neuron that passes along its axon and links or transmit to the dendrites of another neuron. And kindly just dear friends, here I'm not making it towards in depth of biological. Axon is not technically touched dendrites of another neuron. The process is called synapse for receiving and transmitting the signals. What if the concept mentioned here or artificial? What if? So here artificial neural network, there it just comes. And here with biological notation, and of course, let me just demonstrate and take a technological approach in this graphical representation. And kindly just observe, dear friends, here we just have x1, x2, and x3. And of course, till xn, is considered as multiple neurons, that is presumed to be a multiple sensory, transmitting signal to a single neuron. Okay, and let us assume a scenario for this. You are going to watch a horror movie with a friends in a theater. So there is a particular scene where the whole theater gets erupted for a horror scene, and you are having horror phobia, okay, fear of watching this. So for that scene, what you do, assume x1, okay, eyes, x2 would be ears, and x3 would be mouth. So these are the exact input. Then what about your output B? So you will automatically close your eyes or close your ears or scream more. So in such a manner, as per to the scenario, we have terms like what would you do? So these it in the term as like weights. So here it is the input from x1, it is with the weightage of x2, and of course, even you can just say screaming. So the voice where you just scream may be louder or be lower. So that comes towards the each and everything as like a weight. And here, dear friends, weights are crucial for artificial neural network function because weight are how neural networks learn. By modifying this weight, yes, by modifying the weight, the neural network decides which signal is significant in each case and which signal is not relevant for neurons, or which signal is passed or which signal is not passed, or to which intensity signal is passed, and they are the things that can be adapted through the learning method. So like when you are training this artificial neural network, you are basically adjusting all these weights. And kindly just have a note, that's where gradient descent and backpropagation comes into play. So for the same scenario, you will be having the priority, right? Which part has the highest weightage to process, or here by default, we close our eyes or we scream like that. Okay, so here with this input, there would be some output as like our response or our reaction. Now, of course, till we are not yet fully specified about artificial neural network. So kindly just observe here, dear friends, artificial neural network are created to replicate how human brain process data in computer system. So neurons within interconnected units collaborate to identify patterns, acquire knowledge from data, and generate prediction. And here, artificial neural network are commonly employed in activities such as identifying images or processing language and making decisions. So like human brains, artificial neural network are made up of neurons that are connected like brain cells. So these neurons process and receive information from nearby neurons before sending it to another. And here I just to show you the exact architecture of this artificial neural network. There are three layers in our architecture. That is input layer, and here hidden layer, and the third one, it is output layer. And kindly just have a note on to this. Here hidden layer, yeah, it can be one or more than that. And dear friends, a typical feed forward process information is in towards the direction where from input to the output. And again, because of numerous layers or sometimes referred to as multi-layer perceptron. And it is possible to think of a hidden layer as a distillation layer, so which extract some of the most relevant patterns from the input and sends them on to the next layer. And here the next layer is the hidden layer. Okay, so for further analysis, it accelerates and improves the efficiency of the network by recognizing just the most important information from the input and discarding the redundant information. And kindly just observe, dear friends, there are so many benefits of making use of this artificial neural network. So artificial neural network can learn and model non-linear and complicated interactions. So which is critical since many of the relationship between input and to the output in real life are non-linear and complex. And dear friends, artificial neural network in machine learning can generalize after learning from the original input and their association. So the model may infer unknown relationship from anonymous data, allowing it to generalize and predict unknown data. And of course, here I want to add up one thing. Artificial neural network does not impose any constraint on the input variable, unlike many other prediction approaches like how they should be distributed. So furthermore, numerous studies have demonstrated that artificial neural network algorithm can better simulate heteroscedasticity or data with high volatile and non-constant variance because of their capacity to discover latent correlation in the data without imposing any present association. So this is particularly helpful in forecasting. Of course, forecasting may be mainly on towards this financial items as like stock prices when significant data volatile would be happens. Okay, and coming towards this types of artificial intelligence, artificial neural network. Dear friends, of course, here I have just given you 6 types of artificial neural network. And yeah, there are few things is there which is very most used for them. One is feed forward. And yeah, today we are discussing on towards this convolutional neural network and recurrent neural network. These are very much important. Yeah, let I just give you one by one. So first, this feed forward neural network. This is the simplest form of ANN. So data travels only in the one direction. That is, which I just previously said, no? That is feed forward only from input towards the output. Okay, this is the example we just looked at. When you actually use it, it's fast. When you're training it, it will take a while. Almost all vision and speech recognition application use some form of this type of neural network. Next, it is radial basis function neural network. Dear friends, this model classifies the data point based on its distance from the center point. If you don't have training data, for an example, you will want to group things and create a center point. So the network looks for data points that are similar to each other and groups them. So here, one of the application I can just say, there's actually a power restoration system. Of course, that would be a very much important thing. And next one, coherent self-organizing neural network. Here, dear friends, of course, vectors of random input are input to a discrete map comprised of neurons. And here vectors are also called dimensions or planes, you can just specify. And towards the application, of course, you can using it to recognize patterns in data like medical analysis. Of course, this type of neural network would be used. And what I just specified it as a recurrent neural network. Dear friends, in this type, the hidden layer saves its output to be used for future prediction. And here the output becomes part of its new input. And of course, application includes like text to speech conversion would comes under here. And when coming towards this convolutional neural network, okay, in convolutional neural network, the input features are taken in batches as if they passes through a filter. This allows the network to remember an image in parts. Applications includes signal and image processing, such as facial recognition, would just comes here. Okay, last but not least, model and neural network. So this is composed of collection of different neural networks working together to get the output. And this is the cutting edge and is still in the research phase. Okay, here I just want to make you in a mathematical manner. And let me just summarize what it is, the neural network. Dear friends, signals from multiple neurons as like x1, x2, x3 and till xn. Okay, here it is x4. Let I just specify till xn along with associated weights w1, w2, w3. Of course, let I just make it xn. Here it is wn. Okay, are transmitted to the successive neurons. So here this is what the input layer. So after we are receiving this multiple signals, that is here consider it as like a neuron. So with weight associated with it, we will be summing up all the signals with weights, and that's our, here it is what it is specified as like the first step. So here we are summing it up. And of course, we are just going to pass it towards the next layer, which is the hidden layer. And dear friends, it applies to the activation function. And here that is specified as like a hidden layer. And if the neuron passes the signal, or if you are just specifying anything towards the pass or need to the pass or the signals or not, and if the neurons pass the signals, that is towards the another, and yeah, you can also have n number of hidden layers, and lastly, once after you are received with some output. And here, of course, this is also a neuron. So if the neuron passes the signal, there we just get some output and it would be resulted in the output layer. And here, dear friends, you can repeat it this one till when? Till you are satisfied with this output. And how come you just repeat it? Of course, you can just make a variation of this weight, where of course it is not in the neural network. Of course, you are just going to make it into the next part of convolutional neural network. And dear friends, finally, when you just go with this neural network, yeah, it is a sequence of algorithm that imitate human brain's function to recognize connection between huge volume of data. Of course, this is the base of deep learning approach. And here I'm just specifying one important thing, activation function. And of course, here also we are having that. And what is that activation function? Actually, what the activation function do? Difference activation function is a function that is added into the artificial neural network to help the network learn complex patterns in the data. When comparing with the neuron-based model that is in our brain, the activation function is at the end deciding what is to be fired into the next neuron. It takes into the output signal from the previous cell and converts it into the some form that can be taken as the input to the next cell. It's a non-linear transformation that we do for inputs that we receive before sending them into the next layer or neurons. And kindly just have a note on, dear friends, this is activation function is also known as transfer function. So basically, activation function can be classified into as like a linear and a non-linear activation function. In simple, without activation function, the output signal will be a linear functions. And polynomial of 1 degree or as a linear regression model, this can be. But they have less power to learn the complex functional mapping from the data. And here, activation function captures a non-linear relationship between the input and also converts the input to a useful output. But our brain functions non-linear for complex calculation, robustness, and high parallelism, ability to handle imprecision and fuzzy information. So for this to mimic, we need activation function. to work in a complicated, high dimensional and non-linear large data set. That is what the main thing, large data set, and that has complicated architecture. Here I just want to specify, of course, previously I just go towards the previous slide. See, kindly just observe, this is X1 and the product of X1 and W1, that is weight 1. We are summing every inputs. So here, of course, what is X? Here, the X, it would be weight plus input. And of course, here we are not ending, we are adding with the bias. And of course, dear friends, an activation function is applied towards this result by y is equal to f of x. And here, what is this x? Of course, we have that is weight plus input plus bias. And how many weights or how many inputs? Of course, we have n number. So we have to sum 8 and sum of these activation with weight and towards the product towards input and adding towards the bias, that we just get it in our output layer. So finally, the output from the activation function moves to the next hidden layer and same process is repeated. So this forward movement of information is known as forward propagation. And what if the output generated is far away from the actual value? So using the output from the forward propagation, error is calculated. So based on this error value, the weight and bias of the neurons are updated. So there would be a repetition here. I just already specified, which we just say it as a backward propagation. Let I just come it into the further slides. Okay, here, of course, dear friends, we have so many activation functions is there. The first one, let me just go with the sigmoid function. The sigmoid function is used when the model is predicting probability. Next, the threshold function. So the threshold function is used when you don't want to worry about the uncertainty in the middle. So there you can just make use of this threshold function. And very much important towards this ReLU function. So ReLU, actually, it is a rectified linear unity. So this exact function gives the value, but says if it's over 1, then it would be just 1. If it is less than 0, it would be 0. So the ReLU function is most commonly used these days. And next, it is all about the hyperbolic tangent function. So hyperbolic tangent function is similar to the sigmoid function, but has a range of -1 to 1. Okay, let I just show you a small thing. I just want to show you a code where you can have a look onto what is an activation function. Hope I think you are able to see my code. Yes, yes. Okay. So yes, dear friends.
Visible.
Yeah, thank you, Prashant. Yes. So yes. So here, just I go with a small each and every description step by step. So the first thing, what I have just given is the required libraries. One is as NumPy. You have to make a numerical component, and towards the matplotlib, I'm just giving here to show you a graphical output. So I have just used this. And next, of course, I want to give or define an x-axis value. And here I created an array and of values ranging from -5 to 5 with a step of 0.01 to get a smooth curve. So let I execute this. Excuse me. Okay. Now next here, of course, here I have just given you a small function to plot the exact output. So I have named it as a plot. And what is the white limit? And towards the locator. And kindly just to see here, this is what the function is responsible for plotting activation function. And I have just given the x-ticks and y-ticks with a font size, specified font size, and the locator param with the 5 bins. And of course, I just need a horizontal and vertical line in a black color. But when I'm just plotting it in a grid, I need it to be in a red color to show you in elegant manner. Okay, and let I just execute this function. So here it ensure a consistent size across all the plots. So I have created this plot, and wherever needed towards this plot, I am just going to call this function. Okay, so let I just go to the next one. Here, I just need a binary step to have this vectorization. Actually, this function outputs 1 for positive inputs and 0 for negative inputs, though that is what I have just given it in a lambda function. And first of all, let I just execute this. Okay, so see here, if it is 1 or more than 1, we just get the 1 functionality. And if it is not 1, of course, here it would be as a 0. Actually, whenever you need this particular function, that is when we just specify this particular function as, yeah, I just need this to be only one particular input, or I just need it towards a specific functionality, you can use this. That is binary. It is ones or 0. In that manner, you can use this particular activation function as like binary. And next, we just go with the bipolar. And kindly just observe, dear friends, of course, you all know here the outputs would be -1 instead of 0 for a negative outputs. Okay, it would be -1 instead of 0. So I just show you the output here. Kindly just observe. So see here, instead of 0, it would be -1. Okay. And the next, of course, the most used sigmoid activation function. For this, I have just given 1 by 1, 1 plus to the exponential of -x. So this is the exact function of the sigmoid. Of course, you can just make use of the sigmoid of function itself, call function itself. But here I have defined it and I want to show you the plot. For that only, I have just defined it and called that particular function. And kindly just observe, dear friends, it would be an S shape, that is logistic curve, that squashes the input into 0 and 1. And of course, it is very much used in probabilistic output in, of course, mainly in binary classification. One particular thing I have to add it here in sigmoid, it is actually, yes, it is prone to vanishing gradient problem. So that is what the one main disadvantage is here. And next, I just go with tan h. Actually, this is what hyperbolic tangent function. And of course, I also giving this towards the exact equation. And let I just plot it here. Kindly view the plot. It is similar to the sigmoid, but of course, as I have already specified, here it would be -1 to 1. The range, it would be -1 to 1. And of course, it is better than sigmoid because in center, the output around it is in 0. But here, kindly just observe, here it is not 0. It is 0 to 1. That is what the sigmoid. But when you come towards this tan h, of course, here towards the intermediate, we can have a center value also. Okay, next, of course, ReLU. And yes, this ReLU here, X for positive input and 0 for negative output, sorry, negative input. So kindly just observe. And of course, previously I just specified about the vanishing gradient. Of course, here this ReLU would solve vanishing gradient problem. And of course, computational efficiency also, here it is very much high. So yeah, I have used more occurrently about this. But one disadvantage, it is, of course, there is one specified problem. They say dying ReLU. That is, neuron can output 0 and stop learning. Okay, in such a case, what we can just do, of course, we can go with this leaky ReLU or ELU functionality. Okay, and here what is leaky ReLU is in the sense, of course, here it is as a small modification of ReLU. So see here a small negative value, that is 0.1x as like a learning rate or whatever you can just specify, or allowed instead of 0. Okay, and of course, the main advantages here, it is used to prevent the dying ReLU problem. So that is it specified as well, leaky ReLU. And one more thing also we can use related with this dying ReLU, that is exponential linear unit, which we just shortly specify as ELU. So similar to leaky ReLU, but uses an exponential curve for negative output. So see here an exponential curve for a negative inputs. And of course, it has a very good advantages, that is help small gradient in a negative range. And last but not least, the soft plus. And of course, this one, yeah, kindly just observe a smooth approximation of a ReLU functionality. And here it ensures differentiable everywhere. So yes, dear friends, these are the exact activation function. And of course, each activation function has its own strength and weakness, and their choice depends on the problem being solved, or where you are going to use, or for what purpose you are going to be you are going to include this function. So there it differs. Okay, so yes, let me just go back to the presentation. So here. So yes, dear friends, so we have discussed about what is this activation function and where it is used. And of course, more would be just having some confusion, choosing which function or which activation function is right. Dear friends, we have seen so many activation functions. We need some logic to know which activation function should be used in which situation. A good or bad, there is no rule of thumb. So however, depending upon the properties of the problem, we might be able to make a better choice of easy and quicker convergence of the network. First of all, sigmoid function and their combination generally work better in the case of classifier. And here sigmoid and tanh function are sometimes avoided due to the vanishing gradient problem. I have already specified ReLU function is a general activation function and is used in most cases. And if we encounter a case of dead neuron in our network, the leaky ReLU function is the best choice. And always keep it in mind that ReLU function should only be used in the hidden layer. And as a rule of thumb, you can begin with using ReLU function and then move over to other activation function in case ReLU doesn't provide with optimum result. Okay. So yes, dear friends, here this is what very much important, where and when to use it. Okay, now I have to add this one, back propagation. Of course, I have already specified, that is we calculate the total error of the output node and propagate these errors back through the network by using a back propagation to calculate the gradient. So there this back propagation is mainly used. And then we use an optimization function such as gradient descent to adjust all weights in the network with an aim of reducing the error at the output layer. So this is what it is specified as like a back propagation. Now I just give you a small exact demo of how this convolutional neural networks works. So kindly just observe, dear friends. So here I'm just giving you some nodes, and these are the inputs, a square, a circle, and a triangle. And I just want to give it towards these neurons. And of course, we already have just seen about the neural network. That is input layer, output layer, and of course, more than one hidden layers you can just have. Now let me just give one such an input, and I want to identify, yes, this is a circle. But kindly just observe here, I'm just going to give it into a 28 into 28 pixel. So totally we have 784 neurons here. And one zone passing towards these neurons. Kindly just observe, dear friends, when you are just passing, yes, of course, with a weight and towards the bias, it is added. So each and every X, we are producing it with the weight and passing out into the neurons. So when you just have this, kindly just observe x1.8 plus x3 into 0.2. So that rate just going towards this B1 bias, and yeah, which act as like an activation function. And when on just making this, further it just goes towards the next neuron. And with this combination, we would just get an decision making, and we are just going to have our output with a resultant of this forward propagation. And when on just getting our output, kindly just observe, dear friends, what we just get. Of course, we have just inputted a circle, but we are getting the higher possibilities of the square. And in manner of this performance analysis, so calculating on towards this total error, of course it is a wrong prediction, so calculating on towards this total error, what we just get is, yeah, we have to make one more iteration, not as like one decided, yeah, we want to make some iteration. So we are deviating it with an actual output, and with this error, yes, of course, we have to reduce this error and we have to increase this actual output functionality. So there we are going to work with the back propagation. So this, what this back propagation would just do, yes, it just makes the updation of these weights. Kindly just observe, there is the change of weight. Okay, so when on changing the weight, of course, we would have a new weight associated with the nodes in consideration with, kindly just see here, this is W1 and W2, all the things we are just having. And with this X3 and of course, B1, B3, B4. So with this association, after back propagation and adjusting weight, kindly just see, we are getting the correct output. So if we now have the same example again towards it, of course, we would just make it on how long we are taking this iteration. So that is comes towards this convolutional neural network. And I just want to give you a small example and towards the input. Kindly just see here, dear friends. So where most of the things, this convolutional neural network is mainly used towards image classification. So image classification is the task of taking an input image and outputting the class. If here it is a class as a cat or a dog or etc., whatever be. Okay. So probability of classes that being describes the image. For human, this task of recognition is one of the first skill we learn from the moment when we just view or when we born, and is one of that comes naturally and effortlessly. And without even thinking twice, we are able to quickly and seamlessly identify the environment we are in as well as the object that surrounds us. And when we see an image or just when we look at the world around us, most of the time, we can immediately characterize the scene and give each object a label, or without even consciously noticing. The skill of being able to quickly recognizing pattern, generalize from prior knowledge and adapt to different image environments, or ones that we do not share with our fellow machines. But here, how this computer see, actually what it is here, of course, when a computer see as an image, it takes image as an input. It will see as array of pixel values, depending on the resolution, the size of the image. And kindly just see here, previous we just seen 28 into 28. And here it would be as like a 32 into 32. That is array of numbers. And here the thing, you can also just specify 32 into 32 into 3. What is this 3 refers to? Actually, this 3 refers to, it is the RGB value. So just to drive home the point, let's say we have a color image in JPG form. So that is what here the computer understands. So the idea is that you give the computer this array of number and it will output numbers that describe the probability of image being a certain class. Here what it is, of course, it is a dog. So what it would be, of course, 80% of the thing, it would be dog. And 20% it can be, of course, maybe towards this phase or anything. You can just say like any images. No, of course, you can just rather on specifying this, it is 100% dog, you can just recognize it. No much more confusion like this. Okay, fine. So when on taking towards this, dear friends, kindly just observe again, I just let you know here the input image, the CNN inputs image is represented by the input layer, and the input layer includes 3 channels which correspond to red, green and blue channels respectively that are displayed in this. Okay, so here we are just taking it as like a RGB image as our input. So the CNN being by taking an input image, which is represented as like a grid of pixel value. And here each pixel typically corresponds to the intensity or color of a specific location in the image. And next it passes towards the convolutional neural network, that is convolutional layer. So these layers apply a set of learnable filter, which is also specified as like kernels. The kernels to the input image. So each filter is convolved with the input image to produce a future map, also known as activation map. So each future map highlights different patterns or features in the input image. So convolutional layer learn to detect various low-level features such as like anything edges or textures or color gradient. And of course, here I have to add one more thing as like max pooling. So this pooling layer are intercepted with convolutional layer to downsample the future map. So reducing their spatial dimension while retaining the most important information. And here common pooling operations include as like max pooling or average pooling, so which aggregate information from small local region of the future map. And of course, here you can have n number of hidden, as I have already specified, so multiple layer. So the future map produced by the initial convolutional and pooling layer or passed through additional layer of the same type. Each subsequent layer learns increasingly abstract and complex features by building upon the represented layer, that is by the earlier layers. So this hierarchical structure allows CNN to learn hierarchical features starting from the simple pattern and gradually progress into more sophisticated representation. And of course, before passing towards the final output layer, see, it is CNN is typically generated by one or more fully connected layer and followed by a softmax activation function. So the case of in such a case of any classification task, you are just making it. And these layers combine the future extracted from the preceding layer to make prediction. For an example, if we just go for a classification task, the output layer presented predict class labels or probability score for each class. So indicating the likelihood of the input image being belonging to each classes. Okay, and how here it is going to work is kindly just see here. Here I just given an example of a convolutional neural network that here imagine there is an image of here a bird and you want to identify whether it's a really a bird or some other object. Okay, and for optional, I have just given a dog and cat here. Okay, or you want to identify whether it's a really a bird or anything. Okay, the first thing you do is feed the pixel of the image in the form of array to the input layer of the neural network. And yes, here we have a multi-layer network used to classify things. So the hidden layer carry out future extraction by performing different calculation and manipulation. There are multiple hidden layers like convolutional layer or ReLU layer, pooling layer that perform future extraction from the image. And finally, there is a fully connected layer that is identifies the object in the image. And dear friends, when on just making this convolutional neural network, a feed-forward neural network that is generally used to analyze visual images by processing data with grid-like topology. It is also known as like ConvNet. So convolutional neural network is used to detect and classify objects in an image. Dear friends, here I just give you a small thing. So if I just let understand the convolutional operation with a two matrix. Here, if it is very maybe complicated or anything as like a different thing. So let I just give you a simple. So let we have A is equal to 5, 3, 7, 5, 9, and 7. So this is A. And when I just go with this B, let we take like this. Okay, I just want to product A and the B. So the convolutional operations, the array would just multiple A and towards the product of the B. See here, dear friends, the first three elements of matrix A is multiplied with the element of matrix B. And the product is summed to get the result. And next, the three elements from the matrix A are multiplied by the matrix. And the product again it is summed up. So the process continues until the convolutional operation till it ends. So that is what it just gives here towards the output. And how the exact layer it would be. So the layer of convolutional. So here when you just see here what it is, of course, from this input image, okay, from this input image, we are extracting the features. And kindly just observe, dear friends, this convolutional neural network has multiple hidden layers that help in extracting information from an image. And the main functionality which I have already specified is convolutional layer, ReLU layer, pooling layer, or fully connected layer. And of course, we had added with the activation function. And lastly, towards the output, we need a flatten to make it as like a single array. So all this combines. And here, this is the exact first step in process of extracting the valuable features from an image. A convolutional layer has several filters that performs the convolutional operation. Every image is considered as like a matrix of pixel value. So let me just consider if this is as like a 5 into 5 an image. So whose pixel values are either 0 or 1, anything, okay? But here I'm just saying it is actually a colored. I'm just giving a small example. So if in such a case, if I just making like this, okay, something as like 5 into 5 matrix. Okay, one more. Okay, so this is our 5 into 5 matrix. I just want to add a filter matrix with the dimension of something as like a 3, 1, 1, 1, 1, 1, 1, 1, 1, 1. So yes, slide the filter matrix over the image and compute the dot product to get a convolved future matrix. And kindly just observe once on making this, how the extraction happening. It just goes on passing it by. It just passes it and identify the features. So from this input feature, it is rectified and it just giving something that is non-negative. Okay. And when on passing towards the layer, that is matrix layer, I have already specified, we are passing it by a pooling. And of course, you can use max pooling or average pooling. When you take towards the max pooling, of course, what is the maximum among this? 6 is the maximum. So I'm taking this. What is the maximum here? 4. So I'm taking the maximum. And 8 is the maximum here and 7 is the maximum here. So with this maximum of this matrix, I'm just making, that is once the future maps are extracted, the next step is to move them to a ReLU layer. What this ReLU does? The ReLU performs an element-wise operation and sets all the negative pixel to 0. And kindly just observe here. Here it is only negative And once after that, we are having a rectified feature map. And towards this pooling, of course, pooling is a downsampling operation that reduces the dimensionality of the feature map. So here we have 4 into 4, which is reduced towards 2 into 2. So here the rectified feature map now goes through a pooling layer to generate a pooled feature map. And the pooling layer uses various filters to identify different parts of images as like edges or corners or any bodies. Or here it is as like feathers or eyes or beak. Like that, particular towards that region, you can just apply the filters. And here how the exact structure of convolutional network would looks as like. So here we are having our input and towards the convolutional, and as I have already specified, we are applying reloop, and towards the pooling, we are getting this output, that is pooled feature. And once after, the next step, it is to process called a flattening. See, flattening is used to convert all the resultant two-dimensional array from pooled feature map into a single long continuous linear vector. And towards this, we are having this as like a continuous linear vector. For that, we are using this flattening functionality. And the flattened matrix is fed as input to a fully connected layer for what? To identify or to classify the image. And of course, here how exactly the convolutional neural network recognize a bird. So the big pixel from the image are fed to the convolutional layer that performs the convolutional operation. And it results in a convolved map. And convolved map is applied to a reloop. I just specified. So convolved map and convolved map to reloop function to rectify, to generate a rectified future map. And next, the image is processed with multiple convolutional and reloop layer for locating particular feature. So for that, we are making use of pooling layers. So with various filters are used to identify anything as like a specific part of the image. And here, pooled feature map is now made towards the flattened and fed to this fully connected layer to get the exact output. And kindly just observe, dear friends, whenever you are just making this, make use of this activation layer. Activation layer introduce non-linearity into the network by applying an activation function to the output of the previous layer. This is crucial for the network to learn complex pattern. Common activation functions such as we have discussed, ReLU or leaky ReLU, tanh, that transforms the input while keeping the output size unchanged. That is the main thing. And towards the flattening, of course, the convolutional, after the convolutional and pooling operation, the feature map still exists in a multi-dimensional format. So flattening converts this feature map into one-dimensional vector. So this process is essential because it prepares the data to be passed into a fully connected layer for classification or regression task. Okay, so let I just give you one more demo of an identifying. One second. Okay, hope are you able to view it?
I can just
Yes,
see
yes,
the
yes.
screen. There's some code.
Okay. So first of all, let I just connect it.
There's some code. I can just see that.
Okay, so here, are you able to see the dog versus cat CNN? No?
Yeah, yeah. Dog versus cat, and I can see a code.
Yeah, fine. That's all. Okay, and I just include some files here. One second. Okay. So here I just want to make you a small thing. Actually, dear friends, here I just made use of this Kaggle API. to download a data set. Okay, so let I just have the setup Kaggle API to download it. And of course, here I just use it for making the Kaggle API to download dataset of dog versus cat from the Kaggle. Okay, this one. And kindly just observe here. Once on downloading, we just get a zip file. Okay, so we are getting a zip file here. And yeah, I have to extract the data from this zip file. And of course, by using the zip file module to extract the data set, I'm just using this import zip file. So kindly just let me wait for a few more minutes to. Okay, in the meantime, I just include some of the images, sample image that I just have it. Some Dagon cat I have. Okay, so now kindly just see here. I have an zip file of dog versus cat, the data set. Let I just make use of this zip file module to extract the data. And observe here, we would get an extracted folder. Yes, kindly see here. We would have an extracted folder. Okay, done. Fine. So now let we just have this. So import TensorFlow here. We are just going to prepare and prepare this training and validating data. So here I'm just making use of TensorFlow and Keras for deep learning. And I just need some layers for CNN. So here I'm just including a convolutional 2D and max pooling for pooling layer, flatten to convert the future to 1D. And here I have just used a dense for fully connected layer. And kindly just make use of, dear friends, here I have used back normalization for normalizing the activation. And here dropouts to reduce the overfitting. So let I just execute this. Okay, done. Yes. And observe, dear friends, in this dog versus cat, kindly just to see here, we have test and train, two folders is there. Okay, so we want to load that images from this train data and test data automatically. So that is inferable labels from this subdirectory which we just have dogs and cats. Okay, so let I just execute and kindly just to see here the image size here we are having 256 into 256 with a resolution, and we are taking a batch size of 32. Okay, so grouping the images into a batch of 32 images. So here, of course, we found 2000 files belonging to two classes. One is for training data, and for test data, we have 5000 files. Okay, now let me just make use of this normalize. So normalizing the image data. So here, yes, we are going to have, kindly just observe here, this exact converts pixel value from 0 to 255 to a normalizing in the sense, wherever it is 0, of course, it would be the same 0, but wherever it is 255, it has to be as 1. So 0 to 255, now it is going to be as like a 0 to 1. Okay, so that is what the normalization. So applying this exact process function to normalize, of course, we are going to normalize the training and validation data. Done? Okay. Now kindly just observe, we are having a convolutional neural model. So here, yes, we are having initializing a sequential model. And next, of course, we have added a pooling functionality. And kindly just observe, dear friends, 32 filters of 3 into 3 size, that is kernel size, it is 3 into 3 with a ReLU activation function. And of course, max pooling of 2 into 2. Okay, so max pooling of 2 into 2. So this is used to reduce the spatial dimension. So how many we have? Of course, this is the first convolutional layer. Okay, so this 3 is the convolutional layer. And here we have a second convolutional layer. And next, of course, we have made use of a fully connected layer. Okay, so this we have a fully connected layer and flatten the output for fully connected layer. And here dense layer. So dense layer with 128 neurons and with a ReLU activation function. And of course, dear friends, we have used batch normalization and dropout to prevent overfitting. Another dense layer with 64 neurons we have included. And kindly just see here, each and every time it would be varied. Okay, and next we made use of a sigmoid activation function. Actually, it is a binary classification, that is 0 or 1. For 0 for cat and 1 for dog. That is what the thing. So for that we used this sigmoid function, and let I execute this. Of course, done. And to have a summary, kindly just observe. So we have made it compiled and we created this one. Okay, so on compiling, kindly just observe, we have an ADAM optimizer, that is to adaptive learning rate. And here binary cross entropy, that is suitable for binary classification. Of course, if it is not binary, you can just go for sparse cross entropy. And here we have made use of an accuracy metrics as like our to track our model performance. Okay, and kindly just observe, let I just have use of this epoch. And for you information, dear friends, here I have just given one epoch to just have one iterations alone, okay, to evaluate. Even if you want to train more, yes, you can increase the epoch. And of course, here I have just connected GPU. I think so I can also make use of 2 epoch. Let me just wait. I show you after 1 epoch what happens, after 2 epoch what it happens. Okay. So more the training, more the performance, increasing the performance. That's what we can say. Okay. So kindly just observe. So 625 images we have. So yes, it is nearing. Yes, yes. Okay, it's done. So kindly just observe and have a look on towards here. We have 65% of our accuracy. Okay, now let I just vary this to 2 and again execute. What are you able to see here? Some increasing in accuracy. So here it is 76. Now, even we are here in first epoch only. We are here in, that is epoch is in the accelerator, the training of the model. Okay, how you are training, how many epochs. Of course, here minimum we would just to have a sample or to have an just to have an hands-on, we would just give 3 to 5 epoch. As here, I just thought of it would take a lot, but using this GPU, of course, it is getting a faster one. So within a short while, we are able to have the first epoch now, and it is getting ready for the second. Yes. So once after second epoch, kindly just observe what is the accuracy. And it is still increasing. Yes, still on increasing. Okay, so we are having a good accuracy once after on increased epoch. Okay. Of course, by using this itself, we are able to see, yes, there is an increase in accuracy and towards the loss and validation accuracy and validation loss. So even though you can just have a plot and you can view it. Okay, and of course, below we have given the plot of training performance. Kindly just to see here, whenever you are having an increased performance in the training. Okay, and of course, towards the plotting the loss functionalities also. So here plotting the training loss and towards the validation loss. So we are getting a reduced loss functionalities is there. Okay, now whatever the thing, we want to have a check now. So let I just give a small check. Are you able to identify the cat JPEG? So here what we have the image. So it is the one we are able to predict it. And let I just go for a dog. And here it is detailed. If it is dog, of course, we just need one as like an output. If it is greater than 0.5, we would get a dog. If it is not, it is cat. So now let I just have a view of, okay, sorry, it is JPEG. So let me just have a view of it. So kindly just see here, it is 1 and it seems as like a dog. Okay. So yes, dear friends. So here we have a good demo onto it. Back to the presentation. I just go here. So here I just want to give you a small slides of what are all the applications of convolutional network till we are having. Of course, there are so many things are there. Only few I have just given here as like image classification, object detection, or image segmentation, video analysis. Even if we just get in towards this each and every topic, of course, it takes late. So let I just give you a small glimpse of this. So multiple label classification, it is one among the thing. Now it is very much trendy. And so here you can have a labels, multiple labels as like blue jean, blue dress, here also black jean, and blue shirt, red dress, red shirt, like this. So when you have a multiple labels, of course, kindly just see here, not only labels here, it is also meant towards the class functionalities also. Okay, so that here you can make use of multiple label classification. And this CNN, it is very much important and mostly used in medical computer vision. As like for binary, you can just go for cancer, whether yes or no, or positive or not. And for tumor, brain tumor, or anything, not only, see, actually, when you just go towards image processing, of course, I would have already specified you. See, image, when you take towards as like a concept, you can have n number of data as like X-rays, CT scan, MRI scan, and further MRI scan, you can just go for functional MRI, structural MRI, or even you can just take towards the methodology, image classification, image segmentation, image reconstruction, image recognition, object detection, object tracking. So many things are there. Of course, segment, instant segment. So there are n numerous things are there when you go with an image processing. And one among the most used past things is COVID, whether mask is yes or no. This is also an binary classification functionality. And towards this, one more thing as like social distancing. Here it is multi-classification, whether the two object here, whether it is nearer or towards the distance. If the distance is increased, so it is specified as like a following the social distancing. If the two particular segmenting is very near, so it seems as like social distancing violation. So that is what given as like one more added as like a count also here included. And here I just want to share you some of my research. And recently, this exact research, it is on neurodegenerative disease, diagnosing the neurodegenerative disease. Of course, here mainly I have just given an example of this as image processing. Of course, neurodegenerative, you can just go with the text also. You can just go with the signal processing, and so many researchers are there. And mainly here towards this image processing, I used CNN to diagnose it. And next, of course, it is an interdisciplinary. This is as like loading arm. Actually, it is mainly used in a mariner outsource functionalities. So here, when on making towards this, there is loading and unloading of a fuel from the exact container towards the outsource. Okay, so they have to clog this clinches. So it has to be an errorless, that is zero error. So using image reconstruction, we just made a small proposed methodology to identify whether it is errorless or reduced error. So that you can just have an errorless thing. So you can just load and unload the fuel so that no spilling would happen. So that one I done it in true image. And of course, you all just know this is also a binary classification of using helmet, whether you weared a helmet or not. So these are all the things that. And one more last one, of course, when you come towards this deepfake detection, that is image processing, now it is very much trendy. And of course, also this is also one among the higher latest trend. And of course, I think you are not able to hear the voice, but here one among the things is okay, so what is the thing is actually here it is creation or generation of a deep fake video that is with a single image, combining that is a deep faking with an video. Okay, so rather than generating detection, it is very much important and it is very much tough. And currently we are in research with that. Okay, and of course, dear friends, I think I have just shared you an enormous information on convolutional neural network. And here it is not towards an end. Of course, there are so many things are there. You can just differ with the data set. You can just differ with methodology, and even varying the activation function, the performance of the output would varies. Okay, and yes, dear friends, if you have any research oriented or research collaborative ideas or the things, you can just contact with them. And of course, this one, whenever you are need a complete solution, of course, contact this education nets. It's really an amazing platform. So, and I really thank for this opportunity. And Prashanti, it's over to you.
Thank you, ma'am. Thank you so much. That was incredibly an insightful session. A huge thank you to Anjana Devi, ma'am, for sharing such valuable knowledge with us. And now it's time for the most exciting part of the webinar, question and answer session. And I'm very sure that many of our attendees are waiting for this part because it's very exciting. And we have so much of love and so many questions from the attendees, ma'am. So considering the time, we will be going with a few questions from the audience. So let's get started without any delay. So the first question says, what is the main difference between artificial neural networks and convolutional neural networks?
Okay, so this is what the first one we just started with. Of course, artificial neural network, a fully connected network where each neuron is one layer is connected to every neuron in the next layer. So they are mainly used for structured data like classification, regression, and pattern recognition in numerical data. When coming towards this convolutional neural network, which are specifically designed for image and spatial data processing. So instead of full connection, they use convolutional layer with small filters, which I already specified as like a kernels, to automatically detect edges, textures, or shapes and patterns in image. The CNN reduce computational complexity by using shared weights, local receptive fields is there, and pooling operations is there, making them more efficient than this ANN for mainly computer vision task.
Okay. Thank you, ma'am. Thank you so much for answering that for us. And we have another interesting question from the audience. So it says, why do we use activation functions in neural networks?
Okay, see, actually, activation function introduce a non-linearity in a neural network, allowing it to learn complex pattern and decision boundaries. If we use only linear activation, the network would behave like a simple linear regression model. So limiting its ability to recognize only intricate relationship in data. And here, of course, we have so many activation function, which I have already specified. That is for sigmoid. It is good for probability. And if it is sigmoid, but with a range of -1 to 1, you can use tan H. And for rectified linear, for the fast and efficient, you can use the rectified, that is reloop. So there are so many things are there. According to its model and the application, it differs.
Okay. Thank you, ma'am. Thank you so much for answering that. So, considering the time, we have only last one question for this session. So, it says, how does pooling helps in CNNs?
Okay, here I have just specified only the pooling in the exact session. Actually, pooling helps reduce the spatial dimension of future maps while retaining important information. And here main benefit is it reduces computational complexity by decreasing the number of parameters. It helps in translation invariance. That is meaning is that is a small change in input, but it do not affect prediction significantly. And of course, it acts as a form of regularization, which reducing overfitting by simplifying feature maps. And as I have already specified, there are two common type of pooling is that max pooling and average pooling. So I think we have just seen only the max pooling. So average it is taking average of the whole. That is as like if you are having 4 into 4. So first 2 into 2 as one average and second 2 into 2 as a one average. So like that we are going to have like average pooling.
Okay. Thank you, ma'am. Thank you so much for answering the questions, and we really appreciate your patience and engagement in today's session. And as we come close to this session, I want to express my sincere gratitude to our esteemed speaker, Ajanta Devi ma'am, for sharing her expertise and valuable insights. Your knowledge and passion has given us a deeper understanding, and we truly appreciate the wisdom you have imparted. Thank you so much, ma'am. And a
Thank
big
you.
thank you to our wonderful audience as well. Your engagement, curiosity, and thought provoking questions made this session even more insightful. We hope you leave with valuable takeaways and feel inspired to apply them in your learning journey. Hungry for more learning? Stay ahead with our webinars, training sessions, and all things knowledge at Education Nest. Don't miss out, connect with us, and be part of our thriving community that fuels growth and innovation. Follow us on all social media for latest updates, insights, and inspiration. Let's keep up the momentum going. Stay curious, stay inspired, and we can't wait to see you at our future sessions. Until next time, keep learning, keep growing, and keep innovating. Thank you so much.
Thank you.